Another projectile motion example. We'll call this one projectile motion number 4. We basically have a cliff. We're going to shoot something off the cliff horizontally, and the things that we know are the cliff is 40 meters high, and we know that the object landed 800 meters out there. So if I were to draw my motion, it might look something like this, something like that. Okay, and we need to figure out what its initial velocity was in the x. Okay, so how much velocity do we have to give it so we can hit a target out there 800 meters? Okay, what do we know in this case, guys? What are the knowns? You guys can help me here. V naught y is what?
40.
V naught y.
0.
0. There you go. We're shooting horizontally. Okay. AY is what? Negative 9.8 meters per second squared. And what else do we know? Y. We know y is negative 40 meters. Given those three things and the previous experience we've had with these problems, what are we usually looking for? Time. Okay, so we're going to go time, and in this case I'm going to put time down because it's basically just going down. So what a kinematic equation would we select to be able to solve for time? Anybody have that one? If we have y, v naught, a, y, and t?
Is that the one you need?
All right, we're using y equals v naught yt plus 1/2 ayt squared, right? Okay. Now the good news about this one is we don't have any initial velocity in the y. That's 0, so that whole term goes to 0. So we have negative 40 equals 1/2 negative 9.8 times t down squared. And you guys have to help me here. We get negative 4.9. 40 divided by 4.9. And then take the square root of that. 3.5. Now guys, can I get some verification on that? Anybody verify that for me? 40 divided by 4.9. Take the square root of that.
I got 2.8.
Yeah, I got 2.86.
Okay, that sounds a little bit more what I'm looking for. So 2.8 what?
57.
57 seconds. Okay. So basically it's going to tell us that projectile, because it's fallen 40 meters downward, if we shoot it horizontally, remember it's going to fall at the same rate as if we just drop it. It's going to take 2.857 seconds to fall. Okay. Now, what do we know about its velocity in the x while it's falling? Would its velocity in the x stay the same the whole time? So we know distance in the x, and we know time in the x. So what should we be able to find out? Velocity in the x, right? Okay, so if we take velocity in the x should be equal to your x distance divided by your change in time. Okay, and we could put change in our x distance there as well. But if we're looking for Vx, we know we covered 800 meters in 2.857 seconds. And we come up with a velocity of, help me out there, what do we got?
280.
Say it again.
280.
280, exactly.
0.014.
But so 0.14, something like that, meters per second. So guys, what we're saying there, if we want to shoot that thing out 800 meters, and we're shooting it off a 40-meter cliff, then we have to have an initial velocity of 280.014 meters per second. Now really quickly guys, if we made the cliff higher, what would happen to the velocity needed to get it out 800 meters? It would go down because it'd have more time in the air, right? Now guys, since we're kind of tying this stuff together, I'd like to kind of throw in some ballistic stuff here. Guys, my brother and I, we kind of argue quite a bit about what type of bullet you should use when you're shooting at animals or whatever, and what kind of gun, and how much gunpowder you load the casings with. And guys, it's kind of interesting. If you're shooting at something and you shoot horizontally, gravity's going to pull your bullet down, isn't it? So if you want accuracy and you want your bullet to be what they call a straight shooting gun, you want that bullet to haul butt. Because if it gets there in a shorter amount of time, it's going to have less time to what? To drop. Okay? But then you counteract that with, usually to get speed, you can get a smaller bullet. A less massive bullet gives you speed. But then if you actually shoot at an animal and hit it, you have to have some mass as well to give yourself a little bit more kinetic energy. And guys, we haven't got here in this class yet, but we will talk about kinetic energy and that correlation between getting there quicker, which gives you a more straight shooting gun, and then getting there and delivering what we would call knockdown power or kinetic energy. And we'll be looking at that equation. It happens to be kinetic energy equals 1/2 mv squared. And so your m's there and your v is squared. So that speed also plays a pretty big role because you're actually squaring the velocity. Does that make sense? And we'll be playing with that when we get into our kinetic energy unit.